Oh my goodness, you guys. I have sour neon gummy worms to be able to eat. So that's going to be fun while we sit here and wait for the next 3 minutes for things to get started. And oh, we screwed up the zoom of the camera. Haha. Oh, and let me turn on the lighting real quick. That's important too. Oh, look at that. We can see my face now, kind of. We can see this side of my face now. The important part. Hope everybody's having a good night while we listen to this attribution-free music from the YouTube Music Audio Library. It's been a lovely Saturday for me. Georgia destroyed LSU in the SEC championship game. LSU played a pretty decent game and we beat them by 20 points, so no real complaints. Oh yeah, and I got a letter from the IRS. Why don't I open that? Let's just get the cortisol levels as high as possible before we get this started. Okay, I owe the IRS $14. Fair enough. I can do that. Let's try these sour gummy worms, see if they're any good as we wait for the problem to arrive. They're pretty good. They're not like too sour, but they're not just sweet either. They're just a little bit sour. And it feels like something that I can eat a fair amount of without it like wrecking my mouth. Oh, that's not true. This is actually decently sour. I just only had one. Man. Hope today's problems aren't too hard. I watched somebody solve some Google Code Jam problems, and compared to that, I'm not very smart. Just a big yikes there. So we'll see how this goes though. Minute and 6 seconds. Just waiting. Oh yeah, and we can plug in our work phone. Which, like, we're not on call, but it'd still be nice. It's also nice. I've started to keep up with my work emails a little bit on the weekend. I don't do any of the work emails, but I get a lot of other emails, and it's nice to be able to get those out of the way, like, immediately. Oh, let's skip this check. Let's go back to the top. Nice. A little bit of water. Got 30 seconds. It's game time. Should have been stretching out. Spent a couple hours in the car today. Need to stretch out my hips because my lower back is really feeling it, and that's because my hips are not appropriately flexible. Can bump the microphone up a little bit so that we can type. Oh. 7, 6, 5, 4, 3, 2, 1. Let's get coding. Day 4, camp cleanup. Space needs to be cleared before the last supplies can be unloaded from the ships, and so several elves have been assigned to the job of cleaning up sections of the camp. Each section has a unique ID number, and each elf is assigned a range of section IDs. However, as some of the elves compare their section assignments with each other, they've noticed that many of the assignments overlap. To try to quickly find overlaps and reduce duplicated efforts, the elves pair up and make a big list of section assignments for each pair. Your puzzle input. For example, consider the following list of section assignment pairs: 2, 4, 6, 8, 2, 3, 4, 5, 5, 7, 7, 9, 2, 8, 3, 7, 6, 6, 4, 6, 2, 6, 4, 8. For the first few pairs in this list, it means with the first pair of elves, the first elf was assigned 2, 3, 4, 2, 3, and 4, 6, 7, and 8. Second was assigned, elves in the second pair were each assigned 2 sections. The elves in the third pair were each assigned 3 sections. One got 5, 6, 7. One got 7, 8, 9. Oh, they mean like 2 seat sections. Got it. In this example, a list might use single-digit section IDs to make it easier to draw. Your actual list might contain large numbers. Visually, these pairs of section assignments look like this: 2, 3, 4, 6, 7, 8, 2, 3, 4, 5, 5, 6, 7, 7, 8, 9, blah, blah, blah. Some of the pairs have noticed that one of their assignments fully contains the other. For example, 2 through 8 fully contain 3 through 7, and 6, 6 is fully contained by 4, 6. In pairs where one assignment fully contains the other, one elf in the pair would be exclusively cleaning sections their partner will already be cleaning. So it seems like that So it seems like the most in need of reconsideration. In this example, there are two such pairs. how many assigned pairs does one range fully contain the other? So this one's fully containing that one, and this one's fully containing this one. Okay, cool. So this should be pretty easy for us to figure out. So while Scanner has next line, string section pair equals scanner dot next line. So now we want to create ranges. So int here, let's get our puzzle input actually, so we can see how big these numbers are. Looks like they're like double digit at most, so this is fine. We can use integers. Int for caps lock first left equals. Oh, we want to like split the line by the comma. So I think this is a string thing. Elf assignments equals section pair dot split, and we want it to be this. And then we want to parse. Then we want to split each one by the hyphen and parse it. So yeah, int first left, first right, second left, second right. So now let's see. First left is going to be equals integer dot parse int, and it's elf assignments 0 dot split, and we want to split this based on the regex this, and then we want to take a 0. This is like kind of a gross way to do this, but we'll do it this way for now. So then first right is going to be the same thing but 1, and then second left is the same thing but the second string, and second right is the same thing but the second part of the second string. So let me look at the data. Yeah. Should be good. So now, int first side. So let's see. We can, if the one that fully contains the other has to be wider, unless they're exactly the same size. But that's fine. We can deal with that case just as a second case. So if second right minus second left is greater than, nope, it's got to be first right minus first left. That means the second pair is bigger than first. And let's see, let's just call, we want to count, right? Int count pairs equals 0. If is fully contained, and then we want second left, second right, first left, first right. Then we want, nope, not continue, count plus plus, else, and then we want the same call. Oh, there needs to be a space right here, but we want to flip the order of the stuff on the inside. There we go. Count plus plus. And so now let's write ourselves a little helper function, is fully contained. Private static boolean is fully contained. And this is going to be int big left, int big right, int small left, int small right. Oh, the music's not playing. It's because we switched tabs. Background tabs aren't allowed to use as much compute now. If big left is greater than small left, or big right is less than small right, return false, and then otherwise it should be true, right? Return true. Let me think if that's right. So if big left is greater than small left, that means the left side of the bigger one doesn't overlap the left side of the smaller one. And then if the oh, this needs to be count pairs. I just saw the red. That's what I get for being colorblind. If the right one, if the big one's to the right, then it's no good. Otherwise, we know that it's at most fully contained, so that should be good. And then this just needs to be count pairs. Count pairs. All right, let's give this a shot, see what we get. Probably some segmentation fault or something, except we're using Java. Something's not a statement. First left, first right. Else if, there we go. That would probably do it. $132. It's not quite right. Let's return to day 4. Okay, let's try it with this stuff, because there are several things that could be wrong, and we can debug in detail later. But first, let's run it on this, and the answer should be 1, right? The answer should be 2. Okay, cool. The answer is 1, so let's go through, and this should tell us which stuff is wrong. So let's just go ahead, and we can actually just debug our entire way through with the breakpoint. Cool. Section pair, 2, 4, 6, 8. 2, 4, 6, 8. If second right minus first. So it's going to take us into one of these. Oh, here we go. And then actually this should be, this else needs to be in the wrong place. That's what's going on. Else. If this. There we go. Aha. Okay, cool. So let's stop that. Let's try running it again and see if we get 2 now. Basically, like, if the second pair was bigger, I didn't do anything. Okay, fair enough. So now we take this and we put it back into our data. We come here, we hit play. 305. That's right. Continue on to part 2. Nailing it. Okay, it seems like there is still quite a bit of duplicate work planned. Instead, the elves would like to know the number of pairs that overlap at all. In this example, the first 2 pairs don't overlap, while the remaining 4 pairs do overlap. So we can do the same thing, except instead of is fully contained, we just want like is overlapping. So let's just go ahead and copy this entire thing into our part 2. So now we need a similar thing, except it needs to be is overlapping. And then we need this to get called here. And it actually doesn't really matter the order, but we know the bigger one and the littler one. So do the overlap. Okay, so let's see. If they overlap, then that means that if... So this shouldn't be big left and big right. This should be like first left and first right, like the other one. So let's take this and we can just shove int in there a bunch of times. Wonderful. And now we just delete some commas and we should be good. So if first left is less than first right, and sorry, if first left is less than second right, because we already know they're left right oriented. So if first left is less than second right, then they overlap if first right is greater and first right is greater than or equal to second left. So that means the left pair is on the left and the right pair is on the right, but the endpoints overlap. Return true. If, and so now the same thing should be true for the opposite. So if sorry, second left is less than first right. Oh my goodness, I'm so sorry. And should be second right is greater than or equal to first left, then return true. Otherwise we return false. So let's try running it, and if we get the wrong answer, then we can debug like we did last time. 810. Not the right answer. Okay, so let's go back to our test data. Let's plug it in and let's see what answer we get. Are we high or low? Oh gosh, just closed main. Come on, main, I need you to run. 4. So why is it mad at my test data here? Yeah, 810. Is that not what I put in? 810? So wait 26 seconds. And here, let's add some we're gonna add a debug thing here. Private static final boolean debug equals true, and we'll add this as print statements. If debug, then we can say system.out.println found overlapping we're just gonna write, and this is what's nice is that we can just use this statement regardless. We can just call it private static final void print pair. We can actually just do this same thing here. And then we can look at it and see if we find something that looks weird. So let's first left, first right plus second left, and then we want basically this same set of stuff. Should basically be that. So we just want print pair first left, first right, second left, second right. And we basically want to copy this statement here. Here, let's actually call this yeah. So this, we can remove the found overlapping and then call system.out.print with no lin found overlapping. Wonderful. And then we can remove found overlapping from here. And this will just always print a pair. And so now we can do this same thing, but if it's not a pair, and then we can say else. Not overlapping, and then we can look and try and see if we find anything weird. Okay, cool. So now if we run this, this should run a lot of times. Oh, weird. So this saying this is not overlapping, but that's like obviously incorrect. And so if we look close to the bottom of our file, do we see that some of the pairs are backwards? Where is that? 4361. So if we control F, it should be near the bottom here. I'm not seeing it. 43, 61, 62, 63. Oh, did I just like print this wrong? First left, first right, second left, second right. Oh, well, this should probably be second right. Okay, cool. So now let's take a look at some of this data and see if we find any that are wrong. Not overlapping seems fine. Oh no, well this should be right. Aha, we probably need some equal to's here. So that should probably fix it for us. Let's see if we get the right answer, and then we can remove the debug statements. 811. Really, just one more? Okay, apparently that's all that was wrong. Dang. Well, that makes me feel dumb. Let's go ahead and set this to false. And we can run it one more time. You wouldn't normally leave the print statements in there, but I like to do it to like recognize which what problems I was having. So let's take a second and let's look at the leaderboard, and then we can go back through, clean up the code, and then explain the solution like we do every time. So if we go to the leaderboard, a private leaderboard, view how I'm doing here. Oh, nice. Looks like Puff might have beat us today. Looks like he beat us on both. Good for you, Puff. Yeah, we struggled a little today, a little slow, but that's okay. We know that And if we look at my friend Ryan's, oh, Ryan's right here. So apparently he probably took one of them off of me today, is my guess. Otherwise I would have a perfect 40. Looks like the rest of his friends aren't playing, which is a little bit of a shame. But I'm surprised he stayed up till 11:15 p.m. in Arkansas. So if I look at my own personal stats, yeah, slow day for me, 3,000 and 5,000. That's almost as bad as day one. Normally I live in this sort of, 500 to 1,500 range. Oh, well. Well, let's go back through, put in the problem statement, do all the stuff, and then we'll re-explain the problem right here at the end, which you can skip to using the timestamps if that's something you care about. So here's this. Let's move main back over here, put this in, and then do all the little cleanup stuff that we normally need to do. So let's scroll back up so we can use this as a guide. Everything's fine until we get to here. Yeah, and so this needs to be like this. Yeah, 2, 3, and 4. I got sections 5, 6, and 7. Oh yeah, they're also got 7, plus 8, plus 9. Now we've got another little chart to put in. Some of the pairs notice that they have overlaps. 2 through 8 fully contains 3 through 7. 6, 6 is fully contained by 4, 6. In this example, there are 2 such pairs. Wonderful. It's funny how almost all, but not all of the numbers are covered like that. 305. Also, their styling doesn't quite oh no, it does, because of the, I was gonna say like, oh, they're putting the comma inside of this thing. That's wrong, but it's not wrong because that's an entire line given. This is just an entire line of the input text, so they are being consistent. Again, it would be nice if we had a little text formatter to be able to, or if we could copy this over with styling, but I don't think that quite works. Oh, and this needs to, we need to go back and actually make some things into bullets, like this. That's not gonna do. 7, 3 through. This part's always nice. I know it seems a little bit tedious, but it's actually kind of pleasant to clean things up and know that you left things in really good shape. And it's nice because I'm like really spurred to do that because I have you guys sitting here and watching. So let's go up, and are there any other places? Blah, blah, blah. Yeah, within the first pair, the L's, and then this needs to go like this. So now if we go, things seem generally good, except part 2 needs to go like this. How many points we had before today? No, but I would be happy to figure it out with you. I can just directly show you my stats in our, so if we go to the leaderboard and we go to the personal stats, unclear. You can look at my ranks. I was really slow today. My part 2, I had a bug with like an equal sign in there. But if you look at the ranks, you should be able to figure it out. But I did see that you probably beat me. I also got second place in the other leaderboard that I'm on with some of my work friends. So that's not that surprising. But yeah, if you take a look at the ranks here, you should be able to tell. Go to leaderboard and then go to personal stats. And you should be able to see. Yeah, personal stats should be there. Yeah, stats just shows you how many people have done stuff in total, which is cool. But it's cool, actually. You can see that only... here are the completion stats for each day. Gold indicates users that have each thing represents up to 4366 users. So 7,000 people have completed the first part. 2,000 people have completed the second part. Does that grok with personal stats? No. 7,000 completed both parts. Time 9:08. Yeah, so I beat you on the first part, and you beat me on the second part. Here, I can even show you where I messed up. So in my little comparator here that I have, I had greater than or equal to over here, but I just had straight less than. So for things where the edges overlapped on one of the sides, in particular where one was fully covered, I wasn't getting it. So as soon as I found a single example of that, it was fine, which is why I have these print statements in here, which I've wrapped in a little debug. It's not the cleanest thing in the world, but it made it really easy to debug. And then when I, in the future, go back and look, the more of these debug statements I have, the more I know that I was struggling on a problem. Oh, okay. Is there any other step? Yeah. It took me a little bit to figure out what's going on there too. Well, let me step through and explain the two solutions that I've got here, and then I can call it a night on the stream at least. So for the first part, we're trying to figure out whether or not one section, so for example 2 to 4, is fully contained in another section 6 to 8. And a good example of one that is 3 through 7 is completely contained within 2 through 8. So what I do is I read in the line, I split it into 2 strings on the comma, and then I split it, and then I figure out the first pair, like the first left and the first right section, and then the second left and the second right section by splitting each of those strings on the hyphen. So now I've got the 4 digits that I'm interested in, and if we look at the input text only goes up through 100 on either side, so that doesn't matter. I don't need to use a big integer or anything. Then what I do is I take the bigger pair and use that to determine which one might be fully within the other one. I'm not trying that hard to write good code. Good question. And I say, okay, I take whichever one's bigger, so the bigger section, and I put it first, and I say, okay, give me the bigger section, and then tell me if the smaller section is inside of it, and I wrote that in a little function. So if the bigger section left is so if the bigger section, if either side is inside of the smaller section side, then I know no. Otherwise, the bigger section should start to the left and end to the right of the smaller section, and then I return true. So that part's pretty easy. I do the same parsing for part 2, but I need to figure out whether or not things are overlapping at all. So now what I do is I say, okay, it actually doesn't matter which one's bigger or smaller. Just if the first left is less than the second right, then I know that in theory the first pair is to the left of the second pair. And so now all I care about is the first right side greater than or equal to the left second side. For example, is it doing this or more, right? As long as these two are in this order, then all I care is if these two overlap. And then if the pairs are in the opposite order, then I just look at the outside, those outsides, and then I figure out these insides. Yeah, that is a slightly better way to write the same thing. In fact, why don't we take a moment here and clean that up. Then we can actually just copy this whole thing because there's already parentheses there. There we go. And in fact, you don't even need the you don't even need the if statement, which is really funny. You can just say return that statement, because if return if state we basically have if true return true, else return false. And we could probably do something similar for our other statement. Why don't we clean that up as well? So we can just say return this statement. We can just say return not this statement. And everything should run the same. And we can even test it on our input if we truly care. And let's go ahead and put these on the same line. And we'll add some parentheses for clarity. Some people think fewer parentheses makes it clearer. For me, in this case, I like having everything sort of like in its little logical segments. So that should be better. The other thing that I would probably do is I'd create a little class to like parse this stuff or whatever. But for something that's so small, it should be easy. I haven't read the book Clean Code. Why? What do you have to tell me about it, Ryan? I'll wait for your comment. Go ahead. And then we'll call it a night.